What's up, and welcome to this graph algorithm playlist. And today, not today, in this video, we are going to talk about graph traversal algorithms. So, in the first video, we talked about how do we, what are graphs and how did all this begin, and what's the origin of graph algorithms. And then in the second video, in the next video to that, we talked about the representation of graphs. So basically, in first video, we finally concluded that there are data structures which are which are something like graphs. I mean, graphs are a kind of data structure. We finally concluded in the first video. Then in the second video, we talked about the representation of graphs. Basically, how do we store data in a graph? And you know uh, now now after we talked about how do we store data in a graph, in this video we are going to talk about how do we traverse a graph, or how do we access or fetch data from a graph. Because after you have stored data in your data structure, now you need to also talk about accessing the data. Of course, that's something obvious. If we are storing it so that we can access it later. Now, the point is that so this was the basic discussion about why do we need graph traversal algo. But uh, if I simplify my point and if I talk about much more specific reason, it's because some nodes are more special to a particular node. Let's say if we choose a particular node, let's say that node X. Now, some nodes are more special to this node X than some of the other nodes, and this is very easily seen in a graph with disconnected components. Because in a graph with disconnected components, there are some nodes which can be easily traversed, or let's say we can say that there are some nodes which are traceable from a particular node, and others are not. Some of the others are not. So it's very easily seen in disconnected graphs and graphs with disconnected components. And it's obvious that some nodes are closer, some nodes are far away. So in this way, it makes sense that we find a kind of traversal algo from where so in that we start from a particular node and go to go visit different nodes which are traceable from this particular node, and it has various applications uh, you know in real life. So uh, just I was talking about graphs with disconnected components. We can see that here 1 and 4 share some kind of bond, but 1 and 7 don't, and 1 and 6 don't, because these are disconnected graphs. So now, after we have now we talked about why do we need a graph algo, why do we need a graph traversal algo. Now let's first talk about uh, how do we develop a traversal algo. But before that, we have an information interrupt, and let's see what's inside. So it says, so this is a rule of thumb that says that any data structure should have some methods for performing on it to make it useful. Now, what does it mean? It means that if you have a data structure, or if you're, let's say, inventing a data structure, you must have some methods which you can apply on it. So first of all, insertion, of course. If it's a data structure, the job is to store the data, hence insertion is a must. Then updation and deletion. So basically you may want to change the data later, hence you must have updation and deletion. And then fourth is searching. And we follow the same procedure for graph kind of data structures. We first represented those, and now we are talking about traversing those. And if you will traverse, updation and deletion, it comes as a byproduct. So it will become unuseful if we don't have these methods. So information interrupt was this, and now we talk about how to develop a traversal algo. So first of all, let's talk about what is traversal in the case of graphs. So see, we are following a step-by-step procedure. We first talk about why do we need traversal algos. Now we are talking about what is traversal. So traversal is basically it is visiting different nodes which are connected to a particular starting node through some path. So basically visiting all those nodes which are traceable from the starting node. And now let's think how to develop a traversal algo. So, as we talked about how we need to visit all those nodes which are traceable from a particular node, so you will just walk on edges and visit every node that comes in the way. So we can search a graph just by just manually doing this thing. But you can do manually if there are very few points. But for a case where there are there's a large number of points, you need a mechanized and systematic version. You need an algorithm. So now our job. So again, I'll repeat the sequence. The sequence is we first talk about why do we need graph algos. Then we talk about what is. So we first talk about why do we need graph traversal algos. Then second we talk about what is traversal exactly. And now we are thinking about how do we develop a traversal algo. And so now we are in the procedure of developing a traversal algo. So it's obviously that the hint, or you can say that a hint is basically you need to take a graph and think over it. So before taking a graph, let's first also think that how in case of different data structures, how do we traverse those. So let's think how we have traversed various other data structures. So when it was a linked list, we start from the head node, and using the pointer which points to the next node, we move towards the tail. And this is how we traverse linked list. If we talk about stacks, we pop the topmost element, and in this way we basically access all the elements. Now similarly, in case of graphs, we will need to traverse the neighbors or the points associated with a particular point. So you move from one particular point and you move on the edges and you move to the next node which is a neighbor to it. And we can traverse on to edges and we will list the nodes that will come in the path. Now this is an important point here. A key point is that while traversing, you should not revisit any node because that's a useless step. If you're traversing, you just need to visit a particular node only once. So whenever you visit a node, mark that node, and if you'll mark, you will have stored you will have it stored that you have visited this particular node, and now you don't need to come back at it, and hence you'll know that you are doing a useless step if you mark it. So a key point to our algorithm will be that mark a node once it is visited. Now let's start thinking, and let's start the procedure of developing our algorithm in an intuitive manner. So we first take this graph and let's take node 5 as the starting point. And now there are three possible initial pathways so you can go from 5 to 1, then 5 to 4, then 5 to 0. And now let's pick any. So now we have started from node 5. I have marked node 5 in blue, and now we move from 5 to 4. And as we have now traversed to 4, now we mark 4 that we have visited this particular node. Now again we have three more ways to go further deeper. Let's choose any one, and we go from 4 to 1, and we mark 1 as we have reached here. Now you see that there's an interesting case. Now we have one more pathway. We can go from 1 to 5, but 5 is an already visited node, and that's a useless thing. Moreover, 5 is the starting point. Why do we ever return to the starting point when we have not yet covered whole of the graph, which is traceable from 5 or from the starting point? So we basically now return to 4. As after returning to 4, we have two more pathways to visit. Hence we return from 1 to 4. Now note, this is an important point. This is returning to 4. It's not revisiting. We have this so we basically fixed it that we will not revisit any node. But this is not revisiting. This is returning to 4, which is different, because after you return to a particular node, you will choose some other pathway, right? So a key point to our algorithm, we can say, is that as we saw that we didn't move from 1 to 5, we returned back to 1 to 4, and now we'll choose some other pathway which is originating from 4. So we can say that once we have covered all the nodes from a particular path or branch, we return to the previous node to shift our pathway. So that will be the other key point to our algorithm. So now let's choose another branch. So simulating it again, we return from 1 to 4, then we move from 4 to 2, and then we'll mark 2 as as we have as a visited node. And now similarly, so doing it again, 1 to 4, then 4 to 2, then mark 2, then we go from 2 to 3, then we mark 3, then we return back from 3 to 2, and then we go from 2 to 0, and then we mark 0. And now again a case arises where we see that we can either go from 0 to 5, 0 to 4, but none of those make sense because they are already visited nodes. So we return back to 2, and then from 2 we return back to 4, and then from 4 we return back to 5. And in this way, we basically traverse all the nodes which share some kind of bond with the starting point. And I have said it many times in this video that it's basically we traverse all those points which are traceable from the initial point we chose. So overall algorithm could be easily said that it's basically take any of the pathways you have at the initial point, choose any of those. There can be many branches originating from the initial point, but choose any of those. You're free to choose any of those. Now go deeper until you cover all the vertex lying in that particular section, in that particular branch, and then return to the point where you can get more pathways to explore. So you come back just like how we came back from 1 to 4 and then chose another pathway. Similar to that, we here say that we return to the point where you can get more pathways to explore. And finally, return to the initial point and your algorithm is done here, your traversal is done here. Now this particular kind of traversal is commonly known as depth first search. And why is it called depth first search? It's called depth first search because you can see that we dive deeper into a particular branch. We don't just touch branches, we dive deeper into that. So you go from we choose a branch, then we go deeper into it, then we return back, we come back, and then we choose another branch, we go deeper into it, and we come back. So it's in this way, hence it's called depth first search. Now so I can assure you that there is at least one more way of traversing graphs, which is a little bit different from this. Although you can reach to that point after tweaking this algorithm a little bit or thinking about this algorithm for some time. I can assure that you can think it yourself also, that how you can traverse the graph in a different way. So so a hint could be that in this graph algorithm which we discussed in this video, we basically chose to go deeper into a particular branch. We chose one branch at a time, and this is a strong hint if you want to discover or develop the other kind of algorithm which is present. So this is a kind of challenge, you can say, that can you think of another way to traverse trace the points related to a particular starting point in a graph. So this was it for this video, and so I'll say that you must think until we meet again. And so until we meet again, I'll say that let's meet in the next video, and until then, bye bye and see you.